The next question which we have is also very important and a highly conceptual problem. We need to find the total number of ways of selecting 5 letters from the word independent, and we also want to find the total number of ways of forming 5-letter words from the letters selected. Now first of all, we'll try to figure out what different letters or alphabets this word has. This word independent has 3 N's, it has 3 E's, 2 D's, 1 I, 1 P and 1 T, 8 and 3, 11. So we take case 1. We want to make 5-letter words. So our case 1 will be, let's say, all 5 different. This can be done since there are 6 different alphabets. So if we select any 5 out of these 6, we can make a word, or we can select 5 letters. So the selection of these 5 letters, which are all different, can be made in 60 ways, and the total number of words that can be formed are 65 into 5 factorial. These 5 alphabets that we have selected can be arranged in 5 factorial ways to form the total number of words to be equal to 65 into 5 factorial, and this 65 represents the total number of selections of 5 letters which are all different out of these 6 alphabets. So this is 6 and this is 120 into 6, that is 720. We'll remember this. Now comes our case 2. Our case 2 will be 2 alike and 3 different. Not 2 alike alphabets we can get from N, E and D. We can get 2N, 2E and 2D. So if we select any one out of these 3, we can get 2 alike alphabets. So this 3C1 represents the selection of any one out of the alphabets N, E or D. Not 2 alike alphabets have been selected, we want 3 different. Now let's say we selected N. So the alphabets which are remained are E, D, I, P and T, that is 5, and we need to select 3 out of these. So this becomes 3C1 into 5C3, that is 5C3 is 10 into 3, 30, and the words that can be formed are 3C1 or rather 30 into, now these 5 alphabets need to be arranged and they can be arranged in 5 factorial upon 2 factorial ways. Since 2 alphabets are alike, so total ways of arranging are 30 into 5 factorial upon 2 factorial. So total number of words formed are, this is 120 divided by 2, that is 60 into 30, 1800. We'll also remember this. Now comes our next case, which is 2 alike alphabets, 2 other alike alphabets and 1 different. Now 2 alike and 2 other alike will come from these 3. So if we select any 2 alphabets out of these 3, we can get 2 alike and 2 others alike alphabets. Hence this is 3C2. Let's say we select N and E. Now we want 1 different alphabet out of D, I, P and T. So 4C1. So this becomes 12, and the total number of ways of forming words are 12 into 5 factorial divided by 2 factorial, 2 factorial, because there are 2 sets of alike alphabets. This is 120 divided by 4, that is 30, into 12 is 360. So we'll try to remember these 2 also. We make a column over here. First was 6 and 720. The second was 30 and 1800. And the third is 12 and 360. The first column represents the total number of ways of making selections of the 5 letters, and the second column represents the number of ways of forming words. Now we can rub all this. Now comes our case 4, that is 3 alike and 2 different. Now 3 alike alphabets can be selected from N or E. So this is 2C1. Let's say we selected N. So the alphabets which remain are E, D, I, P and T, that is 5 alphabets. Out of these 5 alphabets, we need to select 2. So this is 5C2. This is 10 into 2, 20. And the total number of ways of making words are 20 into 5 factorial upon 3 factorial. Since there are 3 alphabets same, this 5 factorial is 120 divided by 6 is 20. 20 into 20 is 400. Hence the next set is 20 and 400. Now comes our case 5, which is 3 alike, 2 others alike. So in this case, we want to select 3 alike and 2 others alike. We can have 3n, 2e, we can have 3n, 2d, we can have 2e, 2d, or rather 3e and 2d, or what we can have is 2n and 3e. So these are the 4 cases possible over here, and the number of words that can be formed are 4 into 5 factorial upon 3 factorial, 2 factorial, this is 120, divided by 12 is 10, so this is 4 and 40. So the total number of ways of making selections are the addition of this, which is 6 plus 4, 10, 30, 60 and 12, 72, and the total number of ways of making 5-lettered words is 3, 3, 2, 0, which is the summation of all these. Hence our final answers are 72 and 3320.